Ever wondered what the future of the automotive industry looks like? Picture a world where our vehicles run efficiently, with longer-lasting and environmentally friendly power sources. Now imagine this power source is something we often overlook, something as simple as table salt. Intriguing, isn't it? Well, buckle up, because we're about to embark on a fascinating journey, exploring how sodium batteries could potentially revolutionize the automotive industry. What if we told you that the key to this future might just be in something as commonplace as table salt? To appreciate the future, we must first understand the past. In the realm of electric vehicles, traditional lithium-ion batteries have been the beating heart, driving the wheels of innovation forward. Born in the late 20th century, these energy powerhouses brought a new dawn for the automotive industry and indeed, the world. Lithium-ion batteries have many benefits to their credit. They're lightweight, compact, and pack a powerful punch, making them ideal for electric vehicles. They have a high energy density, which means they can store a lot of energy in a small space. This has allowed automakers to design sleek, efficient vehicles that can travel significant distances on a single charge. Not to forget, they have a relatively long life cycle, boasting the ability to be recharged hundreds if not thousands of times. But just like anything else, lithium-ion batteries aren't perfect. They have their share of drawbacks that have posed significant challenges. For starters, they use lithium, a resource that is not only expensive but also limited in supply. This has often led to escalating costs and concerns about long-term sustainability. Plus, the extraction and processing of lithium have serious environmental implications, casting a shadow on the green credentials of electric vehicles. Furthermore, lithium-ion batteries have a propensity for overheating, which can lead to safety issues. Remember those news stories about electric cars catching fire? Yes, that's often due to lithium-ion battery issues. And let's not forget the elephant in the room: battery degradation. Over time, lithium-ion batteries lose their capacity to hold charge, reducing the range of electric vehicles and ultimately leading to expensive battery replacements. In a nutshell, while lithium-ion batteries have propelled us into the era of electric vehicles, they're not without their hiccups. They've been great, but we're starting to see their limitations as we push the boundaries of what's possible in automotive technology. But what if there's a better, more sustainable solution? Enter sodium batteries. Sodium batteries, an unlikely hero in the automotive industry. You might be wondering, sodium? Isn't that what's in my table salt? Well, you're right. But it's also the key ingredient in a new breed of batteries that are starting to make waves in the automotive world. So how did we get here? The concept of sodium batteries isn't exactly new. In fact, the early development of these batteries dates back to the mid-20th century. However, they remained in the shadows for a long time, largely due to the dominance of their lithium-ion counterparts. But why sodium? It's abundant, it's cheap, and most importantly, it can store energy in a way that could rival, and potentially surpass, traditional lithium-ion batteries. Let's break down the science in a simplified manner. Sodium batteries work on the same basic principle as lithium-ion batteries. They both rely on the movement of ions from one electrode to another. But here's the key difference. While lithium-ion batteries use lithium ions, sodium batteries use sodium ions. This might sound like a small change, but it has a big impact. Sodium ions are larger than lithium ions, which can lead to more energy storage. This means that sodium batteries have the potential to hold more power and for longer periods than their lithium-ion counterparts. And there's another advantage to sodium. Unlike lithium, which is relatively scarce and often sourced from politically unstable regions, sodium is abundant and widely available. This makes sodium batteries a more sustainable and potentially more affordable option. But of course, the transition wasn't immediate. It took years of research, development, and innovation to make sodium batteries a viable option for the automotive industry. And there were challenges to overcome, such as improving the energy density and cycle life of these batteries. But how did we go from conception to implementation of sodium batteries in cars? Let's delve into the timeline. The journey of sodium batteries in the automotive industry is a fascinating one. The narrative of sodium batteries begins in the late 20th century. In the 1980s, a new breed of batteries was born, and they were based on sodium. They were initially used in stationary applications, such as grid storage and backup power systems. But their potential was much greater. Fast forward to the 1990s, when engineers started to consider sodium batteries for automotive applications. However, the technology wasn't quite there yet. Sodium batteries were too big, too heavy, and too inefficient to power a car. But the seed was planted, and the automotive and battery industries began to take note. As we entered the new millennium, the race was on to develop a sodium battery that could compete with lithium-ion. The first decade of the 21st century saw a surge in research and development. Laboratories around the world were experimenting with new materials, new designs, and new manufacturing techniques. The goal was clear: to make sodium batteries smaller, lighter, cheaper, and more efficient. In the 2010s, the first breakthroughs started to appear. Researchers discovered ways to increase the energy density of sodium batteries, making them competitive with lithium-ion. In 2012, a Japanese company announced the development of a sodium battery that could power a small electric vehicle. This was a major milestone, and it marked the beginning of a new era for sodium batteries in the automotive industry. The following years saw a flurry of activity. Automotive manufacturers started to incorporate sodium batteries into their designs, and the first sodium-powered cars hit the market. In 2015, an American manufacturer launched the first mass-produced electric vehicle powered by a sodium battery. This was another significant step forward. In the latter half of the 2010s, sodium batteries continued to improve. Energy density increased, charging times decreased, and prices fell. The technology was becoming more and more attractive to the automotive industry. By 2018, several major manufacturers had announced plans to transition from lithium-ion to sodium. And now, as we approach the mid-20s, sodium batteries are poised to take over. They're cheaper, more sustainable, and more efficient than lithium-ion. They're also safer, with a lower risk of overheating and fire, and they're scalable, with the potential to power everything from small city cars to heavy-duty trucks. The journey of sodium batteries in the automotive industry has been a long one, filled with challenges and triumphs. But the end result is a technology that could revolutionize the way we drive. It's a technology that could make electric vehicles more affordable, more accessible, and more sustainable. So, now that we have seen the journey of sodium batteries, what does this mean for our cars and the industry as a whole? Scene script. Sodium batteries are not just a new technology, they're a game changer. Indeed, the impact of sodium batteries on the automotive industry cannot be overstated. They are poised to redefine the landscape of electric vehicles, promising a future where sustainability and efficiency go hand in hand. First, let's talk about energy density. Sodium batteries have the potential to outpace their lithium-ion counterparts in this regard. This essentially means that cars running on sodium batteries could travel longer distances on a single charge, a significant leap forward in addressing the range anxiety that plagues many potential electric vehicle buyers. Secondly, sodium batteries could make electric vehicles more affordable. Sodium is far more abundant and cheaper than lithium. As sodium batteries become more mainstream, the cost of electric vehicles could see a significant drop, making them a more viable option for a larger number of consumers. But let's not forget about the environmental implications. Sodium batteries offer a more sustainable solution. The extraction of lithium for batteries has been linked to environmental degradation. But sodium, being abundant in seawater, can be extracted with far less environmental impact. Now, it's not all smooth sailing. There are challenges to overcome. Sodium batteries have traditionally struggled with efficiency and durability at high temperatures. However, recent advancements are promising, with scientists making significant strides in overcoming these hurdles. And then, there's the issue of infrastructure. The transition to sodium batteries would require adjustments in manufacturing processes. This could initially slow down production and increase costs. But as with any new technology, these are teething problems that will likely be resolved as the technology matures and economies of scale kick in. In conclusion, the impact of sodium batteries on the automotive industry is profound. They promise to increase the range and affordability of electric vehicles while offering a more sustainable alternative to lithium-ion batteries. As we embrace this promising technology, we are not just driving towards a sustainable future but a revolution in the automotive industry. The future of the automotive industry is not just about speed or luxury but sustainability and innovation. Today we've journeyed from the traditional lithium-ion batteries to the emerging potential of sodium batteries. They're not just a fleeting trend, but a significant leap towards a more sustainable, innovative automotive future. With their affordability, efficiency, and environmental friendliness, sodium batteries are indeed shaping the road ahead. As we steer into this exciting future, one thing is certain: the road ahead is electrifying.